Hi guys, it's me again, Justin from chemistrynotes.com, and we're starting a brand new section today. Today is the first video on section 10. Section 10 is called Liquids, Solids, and Intermolecular Forces. So I'm just going to do a lot of setup today. We're going to start to talk about intermolecular forces first, and we're going to talk about dipole-dipole forces and London dispersion forces in detail in video number 2. But this video, video number 1, I'm going to kind of set up section 10 for us, and that's why this is such a short video. So section 10 at the top of page 1 of our notes: liquids, solids, and intermolecular forces. Well, we know there are three states of matter, three main states of matter that we talk about in chemistry anyway, first year general chemistry. Three states of matter are gases, liquids, and solids, with gases being the most compressible and the least dense, and solids are the least compressible and most dense. All right, and then the liquids are somewhere in between for the most part. In this section, we'll focus on the condensed states. Okay, we've already had a section dedicated to gases, and in this section, we're going to dedicate section 10 to liquids and solids, the condensed states. So a few more bullet points here. The third one down says we know that the molecules of a liquid or solid are composed of atoms held together by intramolecular forces called bonds. Now, we almost inherently always refer to them as bonds, chemical bonds, covalent bonds, etc. But really a bond is an intramolecular force because it's within one particular molecule. So we know that the molecules of a liquid or solid are composed of atoms held together by intramolecular forces called bonds. But individual molecules, separated molecules, individual molecules are aggregated together in a large sample. Okay? Think of a glass of water, for example. Okay, billions upon trillions and zillions of water molecules are in a glass of water, right? Those individual water molecules are aggregated together by attractive forces called intermolecular forces. Okay, intermolecular forces, not to be confused with bonds or intramolecular forces. All right, so let's move to page 2 of today's notes. At the very top here, I have a star that introduces the first major topic of section 10, intermolecular forces. Intermolecular forces are often abbreviated with the 3 capital letters IMF. So intermolecular forces, okay? The definition, even though we've kind of already played around with the definition a little bit, intermolecular forces, or IMFs, these are forces that cause the aggregation of components of a substance, atoms or molecules, right? Components of a substance to form a liquid or solid. So one more time, forces that cause the aggregation of components of a substance to form a liquid or solid. Intermolecular forces are much, much weaker than bonds. So intermolecular forces are much weaker than intramolecular forces. All right? For example, think about when you have water on a stove, right? If you're going to convert water to a gas, right? If you're going to boil water on a stove, if you start with water, you have liquid water, H2O liquid. And when you're done with the process, okay, you still have water. You still have H2O. It's just in gaseous form, right? You haven't destroyed the intramolecular forces, the bonds, but you have disrupted the intermolecular forces, right? You've caused the aggregation of water molecules in liquid form to break up. You've overcome intermolecular forces. You have not overcome the intramolecular forces or bonds. All right? So intermolecular forces are much weaker than bonds. For example, boiling water causes individual water molecules to go from H2O liquid to H2O gas. Heat supplies enough energy to break intermolecular forces, holding H2O liquid molecules together, But the bonds, namely the two OH bonds, right, are not broken. Those are intramolecular forces, and it requires a lot more energy to break those bonds up. All right, the next bullet point down there, I say the emphasis on intermolecular forces occur between molecules. So if this is one H2O molecule and this is another H2O molecule, these are isolated molecules next to each other. There's an attractive force between those two, okay? That's an intermolecular force. Intermolecular forces occur between molecules. Intramolecular forces, in other words, bonds, occur within the single molecule that you're talking about. Intramolecular forces occur within the molecule. All right, two types of intermolecular forces, right, that we're going to talk about. And we're going to break down dipole-dipole forces further into hydrogen bonding and all that stuff. And we're going to talk about London forces and all that. I'm just setting this up for the second video, okay? So there are two types of intermolecular forces. Number one, dipole-dipole forces. These only occur between polar molecules. We learned how to figure out if a molecule was polar or not back in section 9 when we talked about, section 8 when we talked about Lewis structures and Vesper theory and molecular geometry. So number one, dipole-dipole forces only occur between polar molecules. And then the second type of intermolecular force is the London dispersion forces, LDF. Sometimes they're called van der Waals forces. Sometimes they're just called London forces. But these occur between all types of molecules, okay? But these are the only type of intermolecular force for nonpolar molecules and nonpolar noble gas atoms. So if it's not like you have a choice where you have to be either number one or number two here, okay? Water molecules exhibit both dipole-dipole forces, namely hydrogen bonding, which we'll get to, and also London dispersion forces. The only thing you need to exhibit London dispersion forces is to be a molecule. It says there it happens for all types of molecules or atoms, okay? All right, so number one, dipole-dipole forces. We'll talk about this in detail in the next video. All right, so stay tuned for video number 2 from section 10, our new section, which is liquids, solids, and intermolecular forces.